Welcome back to Roundtail Restoration, everybody. My name's Chris. This is the motor to my 1964 Triumph TR4 that I'm restoring. As you can see, the head is on. I don't have the bolts tightened down yet, but it's in place, ready to go, or to be tightened. I reached out a couple weeks ago and asked, hey, what do you guys want to watch? Motor rebuild, Spitfire differential, overdrive transmission rebuild, or some other. And the motor won by a fair margin. The differential was second, the overdrive was third, so I'll try to get to the differential next. But I want to give you guys what you want to watch so that you hang around, you stick around, you watch the channel, right? Support. I appreciate that as always. So we'll show you what I did here. A couple other things. My rocker shaft assembly, I had to send that away to get that refurbished. I'll show you why here about halfway through the video or so. Thing was a hot mess, frankly. I got the timing chain tensioner on, a couple other things in the video, and obviously the heads. Ought to be a good video. Thanks for watching. Let's get it sorted. First thing we'll look at cleaning up here, some real low-hanging fruit, I guess. This is the drain cock on the side of the block. This thing comes apart. As far as I know, this looks original to me. You can still get them and they appear very similar to this, but I don't know if they are. But essentially got a cotter pin here. We're gonna get the cotter pin out, and then the whole thing will essentially come apart for you. Just kind of unravels. Might be corroded up pretty good. But you got a little retaining washer there, a little spring, and then a little cam, all that stuff. Another little washer, cam, all that stuff should pretty much just come right off. And then this piece here, I'm hoping will come out because it does turn, or at least it used to, but not now. All right, so what I'll have to do is I'll go and put it in a vise real quick and then just try to persuade this guy a little bit. And I believe it will just pull right through. It's just a little ball valve, I believe. And then we'll get that down to its component parts, and we'll clean all those up and put it back together. It's just brass, so there's not really any degreasing or anything. I'm just going to use a brass wire wheel on the bench grinder to clean it up. So let's get this valve body out of there, the ball out of there, and get this stuff cleaned up and make it looking like new. Got all the pieces, parts here all nice and cleaned up and shiny. So essentially it kind of only goes together one way because this is beveled. You can only go in from the large end, and obviously it's not going to fit. So that handle goes in, and then you have this cam here, and what the cam does is it prevents it from rotating all the way around and just gives us some stopping points. So the cam, you can see that hole is kind of squared off at the top and the bottom, and that's going to match this portion of the valve handle, or the ball, or the cone, I guess in this case. So when you get that on, that fits on like that, and you can only go so far. If I can show you without putting it all the way together. Turn the valve, and then that will stop because the squared off part of the ball hits the squared off part of the cam, and then that smacks into the valve itself, the body. And then when you go the other way, the opposite happens. So this is a little beat up, so you've got a divot kind of in the brass here. This cam, it was okay, but then the squared off piece on the handle here is a little worse for wear, but I don't see any problems with it that it's going to prevent it. It's not like you're going to operate this thing all that much. All right, so we'll get the valve in there, the cone, put the cam on, get that lined up just so it sits flat. A washer goes on there, one of the brass washers, and then the spring, and then another washer, and then that washer is going to essentially get clamped with the spring, and then you got a cotter pin. It's going to sit through that hole you saw me take it apart the first time, and that'll get it all cinched together. Now I don't know how easy this spring is going to be to compress, but I should be able to do it with probably blocking some of the shot here, but essentially just try to compress that and get that cotter pin going. Got that in there. What I did is I actually took the vise and cinched it up so it was really close, and then just stuck this in between the two jaws of the vise and pushed, and it pushed down on that spring, and I just dropped the cotter pin right in there, so that worked out all right. So push this in a little bit more just to drive it home. Bend those pin the tines around, and that should work. And it's tight, but it works. Easier to operate when it's in the motor and you get some leverage on it. But there you go. So there's nothing to that. I think they're cool. They're neat looking. I don't think the ones that you can buy aftermarket look like this anymore. So if you can save it, save it. So this goes in the back of the block, and these are not pipe threads. At least I don't think so. No, they're just standard threads. So just cleaning these up. Once you get close to the inside, it gets, it doesn't look like they machined all the way into the block or didn't thread all the way into the block. And this was all gunked up and everything when I got it. Had to like smack actual chunks of corrosion products out of there. So you don't be surprised if it doesn't go all the way in, especially if you're using a tap and not one of these thread chasers like I am. You don't want to start tapping stuff that you don't want to tap. Now that's cleaned up. Use some of that same thread sealant that I did for the bolts up front on the engine plate so that I didn't get any leaky there. This is essentially liquid plumber's tape that you use when you're putting in a new shower head or something like that. That's kind of how I think this stuff works anyway. All right, 3/4 inch, I think. Yeah, 3/4 inch. Nice and snug, but no reason to, kill it. All right, so that looks like that's about all I'm going to get. So that is closed, and that is open. So it's machined just right. Easy to get at, handles in a good spot. Closed when it's pointing at you, open when it's straight down. So there you go. So that's all in, good to go. Obviously a cheesy part of the engine rebuild, but hey, you got to do it, otherwise you're going to have a big old leak. Let's move on to something else. If you watched my last video on setting the cam timing, the one thing I did not do after I get the chain on was to measure the amount of chain stretch. Now the gears here are both aftermarket because they're marked made in Germany, and I doubt the Triumph motors came with those originally. But so I'm assuming that the chain is also not original to the car. But it's a simple check, essentially where you set a straight edge across the chain, like so. And if your links line up, you can, kind of get two flats. And what you're looking for is the maximum deflection between the straight edge and where your chain is. So the spec is actually pretty large. It's about 4/10 of an inch or so. So we'll go ahead and you just push in on the chain as much as you can, I guess, just to, wind that gear to try to get all the slop out of the chain going that way, just to be the most conservative. And then measure it where you have the maximum deflection. And I am looking at about, just shy of 3/10 of an inch. So I got another 1/10 of an inch that I could go in, so that's going to be fine. The chain tensioner will be able to tension that chain up so that you don't get a lot of chain slap and noise, and ultimately, I guess in the worst case, slip a tooth and then eat your motor. That's a real quick and easy check, and we'll move on now to something else. I made a mistake, and I'm going to show you how I'm going to check it and hopefully fix it. So in my last video, I had set the cam timing, and I had a comment from a viewer. And I'm sure it wasn't mean-spirited or anything like that, but essentially the comment was, hey, the way that you're setting that cam timing is not sufficient, especially if you're in a race motor. You could still be a couple degrees off and stuff like that. And I appreciate that comment, and I'm sure it's true. But what the procedure that I was following for the cam specifically was from the manufacturer's instruction of the camshaft. Other procedures that I followed when I did the cam timing in my Spitfire were right out of the tech manual, right out of the workshop manual. So, but it gave me pause and wanted me to reiterate. I know I've made this statement with the Spitfire. I'm not so sure that I've made it with the TR4 yet. But this is only the second motor I've ever rebuilt. If you're watching my videos to learn how to do this right, and that you're going to be correct and the thing is going to run forever, I do not do that. These are not those videos. I would trust Lin and Chef Tush and those guys much more in their engine rebuilds than what I'm going to show you. Don't take what I'm doing here as gospel by any means whatsoever. So, while I think that I have, you know, the proper mindset and the attention to detail and the procedures to do it right. You know, and I think I do, and the Spitfire is a success story so far. You know, there's problems with that car. It's not perfect, but I'm trying to do the best that I can, but this is not the best way to do stuff. Case in point, the bolts for the oil pan, I had made the comment while I was taking it apart, and I never really followed up on it, and then I found in the workshop manual the 2 bolts that go into the very front, into that sealing block that I had mentioned that is made out of aluminum and is easy to strip out. They're supposed to be slightly shorter than the rest of the bolts. I forgot about that, didn't pick up on it. So now I don't know where the bolts are in the oil pan, but hopefully somewhere out of those 19, there's 2 short ones, and the other 17 are gonna be long. So I'm gonna flip the motor over here, and I'm gonna take 1 bolt out at a time and measure it and see if I can't find what the short bolts are, and then find those 2 short bolts, set them aside, and move stuff around and try to make it right. So shame on me, right? I knew there was something going on there, but I'm gonna go back and fix it. So again, not the best way to do a motor. It's the way that I'm gonna do it. I think it's gonna be successful, but if you're here to get, you know, the best way to do stuff, these are not the videos for you. But thanks for watching anyway. So we'll move on, find those bolts, and then continue. All right, so as I thought, the bolt on the top is the shorter one, the bolt on the bottom is the longer one, and the majority of the bolts. So this, unfortunately, longer one was in that sealing block, and the shorter one was in some random hole. And it was about half of the bolts I had to take apart before I found it. So I'm gonna go ahead and put the short one where it should be in the sealing block. I'll put this long one back in the hole that I just took it out. Check the rest of them, make sure I don't have any. If I remember, and you kick yourself because you know, hey, I think, why is this bolt shorter than everything else? And I made the assumption that is because because all the bolt heads have different markings on them, so I knew they weren't original, and I just made the assumption that whoever was rebuilding the motor grabbed what they needed to grab. Hopefully I haven't caused any damage. I don't think so. It didn't feel like it. I just think it'll bottom out. But anyway, we'll put these bolts back in, get the rest of them checked, go back and torque everything back up, and then fix that mistake. Next thing we're going to take a look at is the rocker shaft assembly. Now this is this rocker here is frozen up. I have no idea what kind of shape this is in. It's also not real easy to get apart. So there's drift pins in either end here. They're like caps, and it's there's like spacers and all sorts of stuff. So as you take it apart, you got to be careful. But it's all gunked up. It doesn't look like anything's bad, but there's like I can feel some friction as I roll this. So it could very well be that the shaft has been worn away, or the inside of the rocker arms have been worn away. Who knows? I may have to get a whole new assembly here, but it's just part of the disassembly and inspection. So we're going to go ahead and try to knock one of these pins out. I'm just going to pick a side and use a drift and just try to knock it out. I don't know how successful I'm going to be here, but we'll see. Try to figure out which side is staked and which side is not, so I can knock out the correct side. So what you can see here obviously is the remnants of the rocker shaft assembly that I started to take apart. I got most of it apart, but then I stopped. The pedestals were very difficult to get off, and I don't know if you can see inside of there or not, if you can, but I started to groove it, and I don't know, I don't know what's going on. So I don't know if it's the shaft is messed up in some way, or what. One of these pedestals is essentially seized on. So there's quite a bit of damage here. If you could see that shiny part inside there, those are the grooves from the spring that just literally wore into the pedestal. It's easy to feel that. There's big grooves. That's probably hard to see, but I think you can see the difference in the color there. Big grooves here. You can hear that on my fingernail. That catches. That's all. So this shaft is shot, and I went on to Rimmer Brothers to some of these bearings in here too, that the bushings are shot, heavy wear on the bottom and not so much wear on the top, and you can even see with some of them on your eyeball the difference in the thickness. So I went on to Rimmer Brothers, I looked at pricing this stuff, and to get everything to the point where I would think what I wanted to replace, you're looking at, I don't know, 150 bucks or so, not including shipping. But then I would have to go to machine shop and get the bushings replaced, and then get them put on the shaft and all that kind of stuff, and that just didn't seem like a real great idea. So I found a place via my favorite forum. They recommended a place out of California that rebuilds all this stuff, and I'll throw a link up real quick just so I don't get the website wrong off the top of my head here. But essentially I emailed them and said, hey, this is what's going on, this is what I've got, and they will rebush everything, rebuild everything that needs to be rebuilt, give you new adjustment screws, and replace the shaft with a hard chrome shaft, and then put it all together for you and ship it back. And I just ship, essentially, here you go, take this, please help, and they'll give it back to you in pristine condition, and it's about $280, not including shipping and handling. So I'm going to get all this stuff boxed up. I degreased it a little bit just so it won't make a total mess. I'll put a little note in there and explain to them what I did, and I apologize for my ineptness here. And then hopefully about 2 to 3 weeks, they said, on turnaround. So with shipping and everything, I'm looking at 4 to 5 weeks probably. I'll get something back that'll look nice and pretty and be ready to go to support the motor. So that's going to put a little bit of a crimp in the rebuild, but probably not too much. So we'll figure out now what we're going to move on to, and I think painting the head is going to be a goal here today. All right, here's one coat of the primer. So now we'll let that sit for about 10 or 15 minutes. I'll turn the space heater on so I get some warmth over here, and then we'll hit it with 2 coats of black. All right, 15 minutes, coat number 2, and then we'll let it sit. Next piece of low-hanging fruit before I get the head going is the timing chain tensioner, and you can see there's grooves in there. They're not real deep. I probably could have reused this thing, but for a couple bucks, why? I bought a new timing chain tensioner standoff, and I'll show you something here. So this is the one that came out of the car, and this is the new one. So if you line those two up, I think you can see the top one there is the new one. The bolt's a little bit thinner, the bolt head, but that's fine. But you'll notice that the threads, sorry for the focus, is protruding measurably deeper. So what had happened is I put the new one in and I bottomed out into the block through the front engine plate and didn't really realize it. And you can, I think, see that the threads got all jacked up. You can't really see because it won't focus. There you go. But so I'm going to go back to using the original one, and hopefully the threads in the engine plate are not that jacked up. I'm also going to use some blue Loctite. I was going to do this anyway because there's not a whole lot of thread there. I don't want this thing coming off and rattling around, so I am going to use a little bit of blue Loctite. So I'll go ahead and clean that up, get some alcohol in there so the blue Loctite isn't adhered to something nice and clean. Let it all dry, and I'll get this thing in. And then you put the thing on, a washer, and a little cotter pin, and that's it. A little bit of blue Loctite on that guy. 7/16. All right, so that's good and tight, and it bottoms out now. The other one didn't bottom out, obviously. It's how I kind of stripped it. And then the timing chain tensioner goes on like that. Not a whole lot to it. And then when you put the cover on, it'll kind of compress that into there. And then a little retaining washer and the cotter pin. All right, get a wrench real quick and bend that around properly. All right, that's all there is to it. Not very high tech, but there you go. So that should work. And then we'll move on to the next part, which I think is going to be putting the lifters in. Can't forget that. And then getting that much closer to getting the head on. So I purchased what they call uprated lifters. The lifters coming out of the car, frankly, not in very bad shape. I did keep them all separate, but you know, with the new cam, I'm going to get new push rods. Might as well get new lifters or new tappets. So really, just the only part that's uprated. There might be some material differences here. I don't know, but you got this little hole drilled in it, and it's supposed to aid with oil flow. The original ones don't have that at all. But surprisingly, they're in pretty good shape. There's a little bit of spalling on some of the surface, the lifting surfaces, so not a bad idea to replace these. You do pay a premium for these things, not a whole lot. I think these are $8 or $9 a piece, but I picked them up from Rimmer Brothers. So obviously you need to get them in before you put the head in, or you'll have to be taking the head back off. So I'm going to go ahead, get these all lubricated with assembly lube and drop them all in. No rhyme or reason to dropping them in now, since they're all brand new stuff with a brand new cam and eventually brand new push rod, so I didn't need to worry about keeping stuff in order. But you would normally want to keep all your push rods and all your tappets in numerical order so you don't mix them up. All right, just as a matter of precaution, just going to take a rag on that stick that I made, clean out the recesses in there, the holes. All right, relatively liberal with the assembly lube, a good amount on the face, and then obviously where it's all going to roll. Battery died on me there, apologize for that, but all the tappets are in. Wasn't very exciting anyway. So now the next step really is to get all the tape and cardboard and stuff off the head, make sure that that all got covered evenly. Get these hold down pins out of here, and then should be able to make a final check of the surface to make sure that's nice and clean. Final check of the head surface to make sure that's nice and clean. Some brake clean and stuff, and then drop the head on there. Get that puppy torqued down, and that'll be it. Relatively major milestone. So what you can see here is I got the timing chain cover on temporarily, got the crankshaft pulley and my Super Whamidine timing wheel on there, gear degree wheel. And what I did not do and thankfully remembered to do is set top dead center. And if you want to see how you set top dead center, you can watch my video on that for setting the cam timing. But I needed to mark top dead center on the crankshaft pulley in relation to the pointer that's on the timing gear cover. So I got just marked it in Sharpie for now. I'll etch it, or I don't know what I'm gonna do. I might even take like the Dremel to it and kind of put a little groove in it. I'm not quite sure how aggressive I want to get to it, so I'll try to be careful now. Maybe put a piece of tape over it or something and protect it. But I wanted to do that. So one other thing that I did not and have not pointed out in the past, I put, like I had mentioned, I got these caps on here in the stalks or whatever you want to call them, just the cylinder liner hold down. And you want to make sure that those are on there and tight. If they come on and off, you know, you don't want to rotate the engine with those things not kind of snug down a little bit. I don't think they need to be incredibly tight. It's not a whole lot of resistance to turn the motor over. But if you leave them off and you turn the motor over, it could be possible to lift the cylinder without, lift the cylinder away just due to the friction of the rings and all that kind of stuff. I'm sure that I haven't been careful, so I'm gonna double check my stack heights here, but I think I'll be okay. But that's just something to be aware of as you go through. There is sealant down there, so that should help with some residual, friction and try to overcome that, but it's just that aircraft gasket maker, which I don't believe actually ever completely dries. So it's probably not incredibly good at holding a seal when you've got some shear friction on it. So just to point that out, I know I haven't in the past, and like I said, I probably am not very good at it myself. Now that we're done with that, we'll go ahead and take this all back off and continue down the path to get the head on. Got the timing chain cover thing off, got the hold downs off, lifters are in, everything's cleaned up. I wiped everything down with brake cleaner, wiped the head down with brake cleaner. Now I've got the head gasket ready to go. It's kind of hard to see, but if you look, this stud, this one in the very, very back here, it's just a little bit taller, I don't know, 1/4 inch or so than these in this line, and then these over here are shorter, so that the head studs are not all the same size. I talked about this when I was putting them in a video quite a while ago, but I had mentioned that the lifting eye for the rear of the block, that goes on this one, so that's why this guy is a little bit longer. So all these head studs are different sizes. Some go all the way deep down, some don't go all the way down. Weird. Pain in the rear to get them right. But the head gasket is a Lucas head gasket that I picked up from British Parts Northwest. That it says Lucas, I'm sure. It says it's made in England, but this is a big bore head gasket for the 89 millimeter pistons that I have on this. Now this is still in plastic here, but you can see, I think, the orange stuff, and that's it's got a fire rings on each cylinder, and it's got that orange extra sealant on there. I do not intend to use any gasket sealer or material at all with this. I think there's two schools of thought, but with this extra stuff on here, I don't believe it's necessary. I'm not going to go with a full copper gasket, which is even softer, and I probably wouldn't use it for that either. But I used it on the Spitfire, but the Spitfire head gasket wasn't, I don't think, is this as high a quality. Like it or not, agree with it or not, that's what I'm going with. I definitely wouldn't use form a gasket anyway. I'd use that gasket cinch stuff that I have, but I'm going to call it without that, mainly because of that stuff that's on there. So we'll go ahead and we'll get this out of the package, get that head gasket down, and then we'll manhandle the head over here. Get the head down. I want to make sure that I've got all my ducks in a row, make sure I don't have anything in my way here that I'm going to trip over. I did use compressed air. I don't know if I mentioned that, to kind of blow stuff out here. You want to make sure that everything's nice and clean, but that's what we're doing. Now I couldn't find any markings on here that said top or bottom or anything like that. I don't know if you can tell now, but there's shiny stuff on here and it's a little tacky. So it definitely has some sort of sealant or adhesive, whatever you want to call it. My guess is it's heat activated. But Lucas is stamped in here, so I'm going to put Lucas up just, because no real reason. So we'll get that slid on here. Feels like I'm forgetting something, so if somebody's yelling at me right now, I can't hear you. All right, so the other thing I want to do here, and you're not going to be able to see this, but I just want to kind of look down and make sure that it's obvious to me that all the holes are kind of lined up, even if they're grossly lined up, that they're lined up, and it looks to be the case. I'll give you a close up here. See that hole right there, it's blind. See this hole over here, it's not. So that tells me, again, that I can put this head gasket on either right side up, right side down. The other thing is I wanted to check is you can see that the head gasket is a little bit bigger than the bore of the cylinder. So that's good because that gives me the big bore size. All right, blow this guy out one more time. All right, again, doing a little mind check here, everything. Head gasket, kind of stick it up in the center here. It's a little unnerving, but I assume that will take care of itself when 60 pounds of head gets put down. All right, I think I'm all right. Here we go. All right, so you do want to, when you carry the head over here, obviously you want to get it lined up so you're not sitting here and put it down, oh, I got it backwards and turn around. So as you walk over here, I'm going to try to make sure that I'm going the correct direction as far as orientation of the head. And like I mentioned, I think that the bottom of the head has been cleaned. Blasted that with some brake cleaner and some compressed air. All right, not a whole lot going on there, not much to it. All the ARP stuff, everybody gets a washer. All right, before I put the bolts on there, actually I'm probably gonna take the washers back off. I'm gonna clean these threads up. I just wanna run the run a brush through these threads just to kind of get any schmata out of them, just so my torque doesn't get messed up. Got the head ready to go here. I chased all of the threads of the studs and of the nuts themselves with just a thread tracer just to make sure that that was all clean. Blew it off some compressed air to make sure that was all clean. The landing spots there for the washers are nice and clean. Now the instructions have you put the ARP lubricant on the threads and the washers and the nuts, so we'll do that. And then it tells you to walk them up in 3 increments all the way up to 110 foot-pounds. And that's the spec from the kit. The engine spec from the workshop manual, 100 to 105 pounds. So only a couple pounds short of the ARP stuff. So I'm not concerned about going too high of a torque that the head or the block might not be able to handle it. But we'll go ahead and get all this stuff lubricated, get it down, get it hand tight, and then we'll walk it up in 3 increments. Get the each one of the kits that you get come with this little tube of lubricant, and I'm doing about a pea-sized amount for the threads here, and then we'll just do a little bit on each washer. All right, there's the washers. Now inside of the nuts. And also the inside and the face of it. One thing to be aware of here is these the nuts are 12 point, so if you don't have, like 9/16 of an inch, so if you don't have a 12 point socket, you're going to need one, because a 5/8 inch 6 point will fit on there, but obviously it's too loose and you don't want to be torquing this thing to 110 foot-pounds with the wrong socket, that's for sure. So just got a drill here. I'm just going to put these down, and got the drill variable torque thing set really low. All right, there's all that. Workshop manual's got a nice little picture in it of how to torque the head. Essentially, you start on the inside and kind of in a circular manner make your way out as far as torquing goes. So we're going to follow the torquing sequences in the workshop manual so we get this thing torqued properly. And I'm going to start at 35 pounds, and I'm going to go to 70, and then I'll go for the final 107 or so. I'll split the difference, and then that'll be set, and hopefully that head will stay on there forever and ever. All right, so we'll start with the middle inner one. All right, 107-ish foot-pounds, all 10. Beautiful thing. All right, everybody, that's all I got. Thanks so much for watching. Leave a comment below. Tell me what you think. Well, the head is on and in place. Corrected a couple of mistakes. Still waiting on the rocker shaft assembly to come back. When I get that back, I'll put that in. Check that I can get good clearances on that before I order new push rods and make sure I don't need any weird sizes or anything. I don't suspect I will, but better safe than sorry to wait. But otherwise, that's all I've got. So thanks again for watching. Your comments, your likes, your subscriptions. I appreciate all that. Keeps me motivated, keeps me going. So have a good rest of your day. Cheers.